The equation of a linear relation can provide us with a lot of information about the key features of a line. In addition to knowing the slope and the initial value, the equation can also be used to solve for the x and the y-intercepts. The y-intercept is where the line crosses or touches the y-axis, and an x-intercept is where the line crosses or touches the x-axis. Recall that the equation of a line can be expressed using the equation y equals mx plus b, where m represents the slope or the rate of change. And remember that the letter b is used to represent the initial value. However, the letter b is also representing the y-intercept. And so you're going to see from this point onwards that we tend to drop the term initial value, and we will refer to the b value as the y-intercept. In this video, we are going to look at the graphs of linear relations, and we will use the graph to identify features such as the slope and the x and y intercepts. We will also review how the equation of a line in y equals mx plus b format can be used to graph a line on a Cartesian plane. So in this first example, we are going to be looking at a variety of graphs of linear relations, and we're going to use the graph to identify the slope and the y-intercept for each, and then we will take those two values and write an equation. So when you're given the graph of a line, I would say the easiest thing to start with, or the easiest thing to identify first, is the y-intercept. So remember, the y-intercept is where the line is touching or crossing the y-axis. So the y-axis is the axis that runs vertically, and for us in this graph it is labeled for us, so we know that this vertical line here with the scale is the y-axis. The blue line is our linear relation graphed on a Cartesian plane, and it happens to be touching or crossing the y-axis at this point right here. So if I were to look at my scale and follow the scale that's given, this point right here where the line is touching the y-axis is represented by the value -5. So I can go ahead and identify my y-intercept right away. Remember that the y-intercept is represented by the letter b. So I can say that my b value is equal to -5. The next thing that I need to calculate or determine is the slope of this line. So when I am given a graph, the easiest thing to do would be to pick out or mark two clearly identifiable points on my graph. So I don't want to pick anything that I think might be a decimal value or correspond to a decimal value. So I'm going to go ahead and pick this point right here that I'm going to mark in red. So that would be the coordinate point 0, -5. And another point that I could clearly read might be here. So this point here, which is at 3 and -3. Once you've marked two clearly identifiable points on your line, you are going to then draw in a triangle or connect those 2 points with straight lines to form a triangle shape. And we are going to count out the units or the values for rise and run. And then we can calculate the slope by using the formula slope equals rise divided by run. So my scale is nice and simple. It is counting upwards or downwards by ones, so I don't need to worry too much about that. I'm going to start at this bottom corner here, and I'm going to count the units for my rise. So this would be 1, 2. So my rise is 2. Now, is it a +2 or a -2? Well, the direction of this line in this question is rising upwards. So because my line is rising upwards, that is going to correspond to a positive rise value. So my rise is just going to be a +2. For the run, I'm going to start at the far left corner here, and I'm going to count from edge to edge. So this would be 1, 2, 3 units. So my run has a value of 3. So I've gone ahead and written out my slope formula, rise divided by run, and now I'm just going to input my numbers. So my rise was a value of 2, my run was a value of 3, If I try to divide 2 divided by 3, it's not going to work out to a nice terminating decimal. So I'm actually just going to keep my slope as a value of 2 over 3. It is perfectly fine to have a fractional value for your slope, and as we move on to our last example in this video, you're going to see why leaving your slope value as a fraction is going to be beneficial to you. The last thing that we need to do is put this information together to create an equation that represents the line that is graphed. So our equation template is y equals mx plus b. So all we need to do is just insert the values that we determined for m and for b. So the y is going to stay the same, the equal sign is going to stay the same. In the place of m, I'm going to put in my slope value, which was 2 over 3. I have an x, and then I'm going to put in my b value. Now, my b value was a -5. So you could say plus -5 like this, but remember there's no point in having two signs side by side, and we know that using our sign conventions, a positive and a negative can be simplified down to just a negative or a minus sign. So you should be writing your equation as follows: y equals 2 over 3x minus 5. So here's a brand new graph for us to look at. So same idea like the example before, we need to identify the slope, the y-intercept, and then put those values into our equation template to build a final equation. So same like before, the first thing that I'm going to start with is looking for my y-intercept. So I know that the y-intercept is where the line touches the y-axis. So here is my y-axis running vertically. And I see that my blue line here touches the y-axis right here. And this value, according to my scale, happens to be a +3. So I'm going to go ahead and write that down, that b is equal to 3. The next thing that we can go ahead and do is calculate or determine our slope. So same like before, I'm going to go ahead, look at my graph, and find 2 points that I can easily read. So it could be anywhere. So I'm going to pick the point here, which was our y-intercept, and doesn't matter where the second point is, I'm going to pick this value down here. Once you've marked 2 points, you are going to draw in the lines that connect those 2 points, which makes kind of a triangle looking shape. And now we're going to go ahead and use our scale to find out the rise and the run. So again, before you determine the rise and the run, make sure you check the scales for your x and y axis to know that you are skip counting by the correct number. Again, we have a nice and simple scale here that is just counting by ones. So it's going to be easy for us to count out the rise and the run. So I'm going to start with the rise. Again, it doesn't matter if you start from the top or the bottom edge, as long as you are skip counting by the correct number. So if I count down my rise, I'm going to get 1, 2, 3, 4 units. Okay, so I'm going to fill that in here as a 4. Now, the next thing you want to determine is this going to be a positive rise or a negative rise. You can determine that by looking for the direction. So this particular graph has a line that is running or sloping downwards. So if I go from left to right, the line runs in a downwards direction. The minute you notice that your line is going in a downwards direction, you need to make your rise value a negative value. Now we can go ahead and count out the run. So same like before, it doesn't matter which corner you start with. I'm going to start here and I'm going to count 1, 2. So my run is 2 units. And for the run, same like before, you don't need to assign it as being positive or negative. It's always going to be a positive number. So I'm going to insert those rise and run values into my formula for slope, which is rise divided by the run. So my rise is -4, my run is 2, and -4 divided by 2 is going to give me a value of -2. Our final step is to insert those values for m and b into the equation template to come up with a final equation. So we can keep the y, we can keep the equal sign. We're going to insert our m value, which was -2. Then we have the x, and then you're going to insert your b value, which for us was a +3. So our final equation is going to be y equals -2x plus 3. All right, here's a brand new line. Looks a little bit different than the lines we saw in examples A and B. It's a completely horizontal running line. But same like before, the first thing I would do is identify what your y-intercept is. So here is my y-axis running vertically, and I can see that this blue horizontal line is crossing the y-axis at a value of +4. So my b value is going to be 4. The next thing we need to do is calculate the slope. Now, you could go ahead and calculate the slope using the same rise over run method, which I will show you in a couple of seconds. But what I remember and what I recall, especially from the video where I talked about slope of lines, is that lines that are completely flat or running in a completely horizontal direction, those lines have a slope of 0. Remember, slope is a measure of steepness or how slanted a line is. So if you have a line that is completely flat, like this line here, there is no steepness to it. So the slope then would be 0. Now, if you wanted to show work for this and how you use rise and run to calculate a slope value of 0, you could still map out or draw out the rise and the run. So for a line that is flat like this, there is no rise. It is not rising or slanting or sloping in any kind of vertical direction. So for this line, there is no rise, and so the rise value would be 0. There is, however, a run, and you could calculate that or map that out. So from end to end, if I skip counted, this would be 1, 2, 3, 4, 5, 6, if you were to go directly from edge to edge. So the run would be a value of 6 units. So if I wanted to use my rise over run, the rise would be 0, the run would be 6, and if you divided 0 divided by 6, you would still get that slope value of 0. So now that we know the slope and the y-intercept, we can go ahead and try to determine our equation. So we keep the y, we keep the equal sign. I'm going to put in my slope value, which was 0. Then I have the x, I have a plus sign, and then I have my b value of 4. Now, seems kind of weird to leave it like this because in math we don't ever really refer to anything as 0x. We could say 1x, if anything, or 2x, or 12x, or a million x, but we never ever use 0x. And just doing some basic math, 0 multiplied by anything, it doesn't matter if it's a number or a variable like x, 0 multiplied by x would just be 0. So if I really wanted to simplify this, I could say y equals 0 plus 4. But then I wouldn't leave it like that because I know that I can do this addition. I know that 0 plus 4 is just 4. So the equation for this line is actually just going to be as simple as saying y equals 4. And it does make sense because if we were to go back and look at this graph, where is the line crossing the y? It is crossing the y or the y-axis at 4. There is no slope in this equation or no x term in this equation because the line isn't sloping in any kind of way. It's completely flat. So the equation for a flat line like this could be something that looks like y equals 4. All right, we're going to end off this question with a last graph here, and this one is a special case, a special kind of scenario that doesn't really follow the model that we were using in questions A, B, and C. And the reason being is because this happens to be a completely vertical line. Might be hard to see here, but the vertical line is right here. It's this blue line running in a vertical direction. So normally the first thing we would do is identify our y-intercept. However, this line isn't crossing or touching the y-axis. It runs in the same direction beside the y-axis, and the y-axis is actually right here. But this blue line doesn't touch the y-axis. It does touch the x-axis, however, and it does touch the x-axis at a value of 2. But there is no y-intercept. So I'm actually going to say there is none. So there is no b value. Now, one mistake that students tend to make is they say because there's no b value, they just say b equals 0. However, 0 is a value in math, and 0 is a value on this Cartesian plane. So if you say b equals 0, that doesn't mean that there is no b value. It means that you're saying the line crosses or touches the y-axis at a value of 0. So be careful. Do not assign a value of 0. You need to explicitly say there is no y-intercept. So you could say none. You could say NA, like not applicable. Just make sure you do not assign it a value of 0. All right, the next thing we're going to determine is the slope. So same like before, you could use the m equals rise over run formula to find the slope of the line. There is going to be some subtle differences here though. So this line does have a rise because it is rising in a vertical direction. So we could count from end to end what the rise would be. And so I could start from the very top. I could start from over here. It doesn't matter. So this would be 1, 2, 3, 4, 5, 6, 7, 8. So we could say there's a rise value of 8. The only issue is going to be the run. There is no run for a line that looks like this. It is not running or moving in any kind of horizontal or flat direction. So we could say then that the run is 0. So if I were to then input those values into my formula for slope, my rise would be 8, but my run would be 0. Now remember from our lesson on slope, a number divided by 0, meaning 0 in the denominator, is not going to give you an actual numerical answer. You could put it into your calculator and try to do the division, but it will just give you back an error, a computational error, and you won't be able to get an actual answer. So this was the line that we said the slope would be undefined. So now the issue is, how do you take a slope that is undefined and no y-intercept value whatsoever? How do you take that information and then put it into the equation template, y equals mx plus b? And the simple answer to that is you don't. This is a case that you kind of have to recognize right away the minute you see that there's a vertical line that it doesn't fit the mold for the y equals mx plus b template. There is no slope, there is no y-intercept. The one thing we do know, however, about this line is that it touches or crosses the x-axis. And it touches the x-axis for this particular graph at a value of 2. So the way that you would express an equation for a completely vertical line is by telling a person or the viewer what the x-axis intercept would be. And so you would simply just say that x is equal to 2. And this would be the equation that would represent this vertical line. So any vertical line would have an equation template of just x equals and then the number of the x-intercept. So this one is a special case that you might want to put an asterisk on and keep it in your notes or in the back of your mind, something that you kind of just have to recognize and say, oh, it's a vertical line. It's going to take on its own equation format or template. In our next example, we're going to take a break from talking about slope and y-intercept, and instead we're going to look at the exact same graphs that we used from the first example, but we're going to identify the x-intercepts for each of these different graphs. So let's start by going back and taking a closer look at graph A. So remember that an x-intercept is where the line crosses or touches the x-axis. So the x-axis is the axis that runs in a horizontal direction. So in this particular graph, we have our line here in blue, and it is touching the x-axis right here at this mark. So if we were to follow the scale, which is skip counting by 1, this is 6, this line here would be 7, this line here is 8, so right in between, which is where our line is touching the x-axis, that would be a value of 7.5. So for us, our x-intercept is going to be a positive 7.5. For graph B, this is where we had the line that was sloping downwards, but it doesn't matter if the line is rising upwards or sloping downwards, the process for determining your x-intercept is going to be exactly the same. So we're going to look and see where our line crosses or touches the x-axis. So for us, that's right over here. So if I use my scale, this is going to be where the 1 is. This is where 2 is. So right in between 1 and 2 would be a value of 1.5. So our x-intercept is positive 1.5. With this graph, this was the one that had a slope of 0 because it is a line that is completely flat or running horizontally. This line, does it touch or cross the x-axis in any kind of way? The x-axis here is down here. Our line is up here. This line makes no contact whatsoever with the x-axis, so it is very possible for there to be no x-intercept. So that is the case with this graph. So for our x-intercept, we're just going to say that there is none. Our last graph was the case with the line that was running completely vertically. Now, this line didn't happen to have a y-intercept, but it does indeed have an x-intercept. And we can see that from the graph that the line crosses or touches the x-axis at a value of positive 2. So our x-intercept would be 2. In our final example, we're kind of going to go the opposite way. In this question, the slope and the y-intercept are given to us, and in each case, we are asked to take that information, write the equation of the line, and then graph the line. So this time, we need to be able to take slope and y-intercept information and turn that into a graph. Normally what we have seen is that a table of values has always been given to us, and then we've taken those data points from the table of values and plotted those points on a graph or a grid, and then we join those points together with a smooth line or a smooth curve if it wasn't linear. But what we're asked to do here now is not use a table of values. We are going to strictly just focus on the slope and the y-intercept and use those pieces of information to make ourselves a graph. It's actually a lot simpler and a lot faster than making a table of values, and students tend to prefer to use this method once they get the hang of it. So the first thing that we're asked to do is to take the given values for slope and the y-intercept and write an equation or build an equation. So this is very similar to what we were doing in our previous example, where we just have to take the m and b values and stick them into the equation template. So our equation template is y equals mx plus b. So in the place of m, I'm going to put in my slope of 3 over 4. I have my x, and then my b value is minus 2 or negative 2, so I'm going to insert that into the template. So the equation for this particular line would be y equals 3 over 4x minus 2. Now we're ready to graph. So the first step to graphing a line, when all you have is the equation or the slope and the y-intercept, is you want to start by putting a dot or a point on your Cartesian plane at the value of your y-intercept. So my y-intercept is a -2. Now, because we're going to be graphing all three of these questions on the same Cartesian plane, I'm just going to try to color coordinate everything for you so you can visually see the difference at the end. So maybe we'll do this one in a red kind of color. So let's head over to the Cartesian plane and we'll take a look at how to graph. Okay, so here is my Cartesian plane. I decided to keep the scale very simplistic, and so I just counted by ones on both my x and my y axis. So I'm just going to label that as well. So this would be my x axis, this would be my y axis. So once you've labeled your scale and you have your grid ready to go, the first step to graphing a line or a linear relation is to put a point on the value of your y-intercept. So for our first example, our b value or y-intercept value was -2. So on my y-axis, I'm going to go down to -2 and I'm going to put a point on -2. So here's my first data point. Once you've marked that on your grid, you're ready to come up with the remainder of the data points. And in order to do that, we're going to have to take a closer look at our slope value. So if I go back to the equation, our slope value was 3/4. Now, this is where we're going to come back to what I said about leaving the slope as a fraction, or why we leave our slope as a fraction. The slope, remember, is the same thing as saying rise over run. And if we're saying the slope is rise over run, that means the top number, or the numerator, corresponds to your rise, and the bottom number, or the denominator, corresponds to your run. Now, rise and run are really important because they're going to give us directions on how to move along a Cartesian plane. So I'm just going to quickly recopy the slope 3/4, and we're going to talk about how to move now. So this slope value is a positive 3/4. Remember that for the rise, or the top number, if it is a positive number, that means you're going to be moving in an upwards direction. So for us, we can see here that this entire fraction is positive. There's no negative associated with it. And so this is a +3. So that tells me then that this is going to be really associated to 3 units up. The bottom number, or the denominator value of 4, that corresponds to the run. The run is always positive, and in math, if a run is positive or a horizontal value is positive, that is always associated with moving to the right. So a positive value of 4 would mean 4 units to the right. So we already plotted that one data point on our y-intercept value. From that data point, we are going to be moving 3 units up and 4 units right. The order in which you move doesn't matter. You could choose to move 4 units right first and then go 3 units up. It's still going to make you land in the same spot. So keeping this in mind, we're going to go back to our graph and we're going to plot out some extra data points to make our line. All right, we're back to our graph. We have our y-intercept plotted. From this starting point, we are going to now move in the direction told to us by our slope. And that was we need to move 3 units up. So I'm going to go 1, 2, 3 up. And then I need to move 4 units to the right. 1, 2, 3, 4. So where I've stopped, which is located at 4 and 1, that is where I'm going to put my next dot, or my next data point. So I'm going to take my pen and I'm going to put a dot at 4 and 1. Now in math, we like to ask our students typically to plot at least 3 points. So we need to do this one more time. So to come up with our third data point, I'm going to start where we stopped, so at this point here located at 4, 1, And I'm going to repeat the same movements. We need to move 3 units up and 4 to the right. So from here, we're going to go 1, 2, 3 units up, and then 1, 2, 3, 4 units to the right. So where I've stopped, that would be located at the point 8 and 4. So I'm going to go ahead and put a data point or a dot at that particular spot. So that would be right here. Now, if you haven't extended your scale that far, that's okay. Just go back in and add in some extra numbers so that way you know exactly where that data point is located. So now we've got 3 points on our grid, and you're going to go ahead and join them together with a line. So when you're joining your points together, make sure you use a ruler, so that way you get a nice smooth line, not like my wiggly line here on my screen. The other thing you also want to make sure that you are doing is that you are extending your line out a little bit past those last endpoints. Don't just join the points together, like exactly at the point. Extend out a little bit, put a little arrowhead on each end, because remember, this line doesn't just exist between these 3 points. You could keep this line going on and on and on forever in either direction if you follow those same movements, 3 units up, 4 units right. Okay, let's try a next example. So this time you have a slope of -3 and a y-intercept of 0. So the first thing we need to do is just write out an equation. So we have our template, y equals mx plus b. And I'm going to insert my slope of -3, and my intercept is 0. Now, is there a point to saying plus 0? Not really. It's like saying plus nothing. So because my intercept is 0, I'm actually going to leave it out. So the equation for this particular line would be y equals -3x. All right, now we're ready to graph. So our first data point always has to be placed on our y-intercept. This time we have a y-intercept of 0. And remember, there is an actual 0 on the Cartesian plane, so we can actually go ahead and put a dot or a point on the 0. So this time I'm going to use green, just so you can see the difference, because we are plotting everything on the same grid. So back on my grid, and I need to put my first dot or point on my intercept, and my y-intercept was 0. So right in the middle of my Cartesian plane on the 0 mark, I'm going to put my point, which represents my y-intercept. Now, in order to figure out the direction on which to move in order to generate the rest of my line, I need to go back and pay attention to my slope. So this time, my slope was -3, and that's it. Not really written as a fraction, it's just a whole number, -3. However, if I wanted to express this as a fraction, what number would go in the denominator? Well, they didn't assign a number, but we know in math, if we don't see a number, it's a 1. So this time, the rise, or my numerator value, it's a -3. Negative for a rise corresponds or is associated to a downwards direction or a downwards movement. So this time, this is going to correspond to 3 units down. And my run, or my denominator value, that is just a 1. Remember, the run is always associated being positive. Positive run corresponds to a movement to the right. So I'm going to go 1 unit right. So from that 1 point that we already graphed, we're going to move 3 units down and 1 unit right. Again, the order doesn't matter. You can move to the right first and then move down if you really want to. Okay, we're back to the grid. So you are always going to start at your first data point that you plotted, which is always going to correspond to your y-intercept. So here's my y-intercept in green. From here, I'm going to move 3 units down, 1 to the right. So 1, 2, 3 units down, 1 to the right. So that takes me to a point of 1 and -3. So I'm going to go ahead and put a data point there. And then again, we want at least 3 points, so I need to repeat the same procedure from this point here. So I'm going to move 3 units down, 1 to the right. So that's 1, 2, 3 units down, and 1 to the right. So that takes me to a point of 2 and -6. So I'm going to put in my point, and then you're ready to join them together with a straight line. If you want to go beyond 3 points and put in 5 points or 10 points, you're more than welcome to do that. So I went ahead and joined my points together with a line, and I made sure that I extended the line a little bit outwards past those endpoints, and I put some arrowheads on each end. Now, does it make sense? Absolutely, because my slope was negative, it was -3, so I should be seeing a line that is sloping in a downwards direction. And if you follow the direction of our green line here, it is indeed moving downwards. And it is very clear that it is different from our first line in red, which had a positive slope, and because it was positive, it was sloping upwards. All right, here's our last example. We've got a line that has a slope of -1/2 and a y-intercept of +5. If you have a graph already going and you want to try it yourself, you can pause the video, see if you can graph the line, and then when you're ready, you can come back to the video and see if it matches up to my graph. Okay, so for this question, the equation that you built should look like y equals -1/2x plus 5. And in terms of the slope, we have a slope of -1/2. And so if we were to assign directions to that, the rise value is a -1, which means you should be moving 1 unit down. The run value is a 2, which corresponds to 2 units to the right. In terms of where to start your graph, you're always starting your graph on your y-intercept value. Our value is a +5, so the very first data point or dot that you plot on your grid should be placed on the y-axis at 5. I went ahead and plotted my equation on my Cartesian plane in yellow. So my first data point I placed on my y-intercept, so that was the +5. From this data point, I followed the directions told to me by my slope. So that was 1 unit down, 2 units to the right. So that gave me my second data point, and then I repeated for the third. So I went 1 unit down, 2 units to the right. So that took me to my third and final point. I joined the points together with a line, I extended them out, put in some arrowheads, and I can see that because my slope was indeed a negative value, it was -1/2, my line should therefore be sloping downwards. So from this point forward, if you are given the equation of a linear relation in the form of y equals mx plus b, you have more than enough information to make yourself a graph. If you wanted to make a table of values, you could use the equation to build the table and then use those coordinate points and plot them on the grid. But as you can see, using the slope y-intercept method is a lot more quicker.